И я рад пригласить первого спикера этого блока, докладчицу Марию Зубченко.
I would like to invite the first speaker, Mariya Zubchenko. She's involved in the questions of Yandex Cloud security and development process of DevSecOps. Let's welcome Mariya.
Группе продуктовой архитектуры Security Compliance Yandex Cloud. И сегодняшний
Security Compliance Yandex Cloud. And in today's presentation, I would like to speak about a framework as SLSA and assessment of the efficiency of the protection of the supply chains in the public cloud. So, a couple of words about myself. I'm involved in the development of services, security in Yandex Cloud, also developed DevSecOps direction, communicated with partners, our users for the development of the scenarios of safe development, and a member of a program committee in FIV DevSecOps. The plan of my presentation will be the following. In the beginning, I will speak about safe development, protection of supply chain, some theoretical liquidation of lack of knowledge. Then we'll dive into what is SLSA, SLSA, and what does it mean for DevSecOps. Then we'll speak about standards of safe development, and then more practical example, DevSecOps pipeline in the cloud at every stage, and then conclusions.
Supply chain attack,
SLCA supply chain attacks, and how serious all of these, if previously there was a question about
насколько эти атаки могут там
how these attacks can subject an organization to any danger. Well, year 23 have ended all these questions because there was a lot of big global companies, big global campaigns, attacks against supply chains. And you can see research here from Traversion Labs. You can follow the QR code and you can see all the details of these global attacks.
Также мы проанализировали еще отчет за State of...
Also, we have analyzed a report on the state of software supply chain security 2024, and there was a very big report and three key moments here that you can take from other. The first one is that the supply chain of the software is still a certain dead spot, blind spot in the development, because we will never gonna be able to see all the chain of dependencies that we're using in our software. That's why we come to the conclusion that all these attacks against supply chain become simpler and changes are coming. These are more about trends of what should we expect in the future. Most likely the approach to development, to the process of development is going to be changing. How do we remember the year 2023? We have discovered about 11,000 malicious packages, according to the research data in some open sources like PyPy and PN, Root Games, and this is 30% more than the year 2022. Also, leakages of secrets are happening through a lot of big platforms. As for AI, if you look at different presentations and other conferences, including this conference as well, a lot is being said about AI securization, safety, and GPT assistance. They are helping from one side, but actually the responsibility for a big amount of leakages is given to OpenAI, which has developed ChatGPT platform. 20% of Python leakages and 4% from the total number of leakages from NPM. This is a very big amount of leakages. And why does it happen? Because there is an absence of certain hygiene, security, and the practice of the code security. There is no concept as safety by design. Safety has to be at every stage of development. And, for example, the framework from Google, like SLSA, supply chains, level of the artifacts, the level of supply chains for the program artifacts can help proper checks at every level. It's a very young framework. New version has been separated into 3 levels. What does it mean practically? Is that the first level is more dedicated to processes. Assembly processes has to be written according to scenarios. They have to be automated. They should generate the authenticity metadata about how the artifact was created. Then requirement is growing from level to level about the control of versions, which has to generate authentified source and subscription of origin of those artifacts as well. And level number 3, it's more hard secure level. It's about scanning for vulnerabilities, compliance to different security standards for the platform where the code is being stored and assembled, and review in 4 eyes or even more. That's understandable. How can we map the SLSA framework? Just a second. Yeah. How can we map this framework for public cloud, and how can we work with all of this in the cloud, not just on-prem? Because I'm an engineer in the Yandex Cloud, I would like to show you an example of how can we build a secure development pipeline in Yandex Cloud. And the complying to SLSA framework, it's divided into several stages as planning, development, assembly, and security of images, deployment, and runtime by itself, because SLSA will be on the side. But we are going to look at the whole pipeline in general. Planning and design, everything starts from designing our solution, and on the safety portal of the Yandex Cloud, we're describing which standards do we comply to. Both, I'm speaking about our standards, international standards, distribution of responsibility, public cloud operations. This is also an important part to understand that you work with cloud provider and you share this responsibility for the safety and security. What are we doing for safety inside of the cloud? And today there's going to be a presentation dedicated to what are we doing inside of the cloud and safe development has been. 3 p.m. in the same track, this presentation is going to be provided. Also, due to the fact that our cloud is 6 years old this year, and we have a lot of expertise about it, big number of architects, security architects, and we have collected all these recommendations about how can we properly work with the cloud and standard of protection of the cloud infrastructure, which is divided into 100-something different checks. It's divided into different sections, and this is some kind of a checklist following which, if you will follow these recommendations, you will be able to check how is it included in the cloud and the instruction on how all this can be applied. If you will map it on SLSA, then this is to the compliance of the security standards of both the platform itself and your standards as well, that you can comply in the cloud. And the process of assembly is automated, and there is origin. And we can be held by service as a managed service by GitLab. This is managed cloud service to work with GitLab service. Generations of origin is happening here in a very simple way. You have add a variable runner generator to effects into metadata, put a Boolean value true in a GitLab's file. Then in artifacts, you will store a file that will be an origin. And you cannot see it pretty well. However, there is a reference that you can follow, link that you can follow, and you can study it in a video that has assembled a little bit. And it covers the first level on SLSA, speaking about assembly automation, because all this process described in scenario CI file and origin is being generated. Then we're switching to the assembly stage and providing image security. We can check our images for vulnerabilities, for statistical vulnerabilities of the code through statistical analyzers, and secrets by adding a pattern template into scenario in CI file. On the right side, you will see, during those moments when I will demonstrate the pieces of code, you will see QR code that will take you to GitHub repository with all these materials and video of how these can be realized and applied in your infrastructure, because I'm going to show you at every stage by little pieces, and I'm going to tell you about that. Secrets cannot be stored in an open code. That's understandable. And in the cloud, there's a service which is called Logbox for creating and storage of secrets, and you can store them out there in a centralized way. Then we go to scanning for vulnerability stage. It is possibly can be done in several ways. For example, in the pipeline, and you can put it as a some security gate in the last line. And last line is about that we can define it differently. For example, if the sum of vulnerabilities is more than one, then our pipeline is going to be fueled, and then we'll be able to have a certain work on errors and mistakes. Also, this vulnerability scanning can be included on the level of UI in the cloud with the help of scanner of vulnerability in container of registry. When you go to the console of the cloud, you can see container registry and this exclamation mark, which tells you that we don't have a single policy for the image scanning, and this can easily be fixed and tuned up. Basically, everything's going to be tuned up. You can tune up by schedule, custom schedule, or during the download of the image into the repository. And it covers the moment that on the third level, vulnerability scanning is being done, and the storage platform for the code and its assembly complies to certain standards. And this is about managed service for GitLab, and not only about that, because in our cloud, we are not testing some specific law or services. We are testing the cloud in total, and all these services do comply to standards which are listed in a security portal. Then we are going to speak about generation of image SBOM. What is SBOM? It's a software bill of materials, list of components of libraries which were created for the creation of this software. Then how SBOM can be generated by open source tool as seed directly in the pipeline. QR code takes you to GitHub repository in order to be able to reuse it, and it's divided into several steps, and subscription of BOM and generation is dedicated to this. How do we sign this as BOM? We also have a signature of the image with the help of K-signed utility, which is integrated with the service key management service in Yandex, and we can sign this image, we can sign SBOM with the block file, we can sign the origin. This all happens in pipeline, and the signature appears in a registry container together with Docker image. QR code is in the documentation on how it can be done, and this is described in 5 steps. What are the SLSA levels? Compliance can cover it. The second level, where we speak about the origin, signature, and other artifacts, and systems of version control. Assembly location, which generates authentified source. Then we move to the deployment stage. First, deployment is happening in some test environment, where we can check for some dynamic analyzer of the code for vulnerabilities, because statistical analyzer can analyze only vulnerabilities of the source code without connection to the environment. That's why, for example, the some dust analyzers we will use open source of ZAP, the lower QR code for its instruction, and in the pipeline in our test cluster, we can send this dust analyzer and check it in the environment. What are our vulnerabilities that have to be fixed from the point of view of possibility of exploiting them or not? And this is also speaking about vulnerability scanning, because we're checking it at every stage of our application. And then let's speak about checking the signature, because it wouldn't make any sense to sign our artifacts if we're not checking this signature. Well, the signature check is happening with the help of this case sign verification. You can do it with the help of Kverno or some other vendor tools, and QR code takes you to all these materials. This is origin signature, and our artifact was not substituted. After this, we have a review of our code, and in order to find out that the review process is being done properly, there's a functionality in the GitLab as a probable merge. In rules of our in approval rules, we have some definite users who can put merchant request, and by these they can check the review property, code review properties. So that's how it works. So that prop wouldn't go into merge request that was not confirmed by various important people. And by this, we're covering all the levels of SLSA compliance, and then we can move to those services which accept in Yandex Cloud the value in other public clouds. They do have similar services as well, and this matrix can be built for any public cloud. Then, speaking about protection on the level of runtime, we have these services to protect from DDoS attacks, like DDoS protection in a partnership with the curator. Then Smart Web Security Service to protect web applications, which has inbuilt web application firewall, which works together in symbiosis with Smart Captcha, which is against anti-robot activities, certificate manager, Captcha for creation of certificates. Also at the bottom you can see the flow that you can select WAF and Marketplace, and Marketplace is some kind of a front window vendor solutions. It has not only Wi-Fi security but some other solutions as well. That's why you can protect application on different stages, both on the stage of development that we had before and on the stage of this runtime. Some conclusions. SLSA is protecting from attacks of the supply chain integrity, because their number has increased by dozens of times, and we recommend to pay attention to the necessity of creating the infrastructure to protect the complicated supply chain. And these are three conclusions: that SLSA in the cloud is real, it's not only on-prem framework. Safety has to be at every stage of your pipeline from level to level. Honestly speaking, the number of requirements is growing, and possibly it's going to be more expensive, but nevertheless, if you're using shift-left methodology, then you're saving yourself from the consequences of those leakages, which financially and reputationally can cost you much more expensive than implementation of different tools. And business shouldn't suffer. And all this big number of checks, if we will apply it in one scope, then business might stop if you will do it once. So some risks have to be accepted, and you should apply different requirements according to the needs and risk appetite of your company. Also, we've been speaking that we have planned several webinars and workshops. 25th of May, Saturday, 2 p.m. in the same place. We're going to have our workshop together with Gilbert team. And all this pipeline is going to be repeated together with you. We're going to tell you how you can protect the software. You will look at how it's being exploited, and then we will build a proper development process. This comment is going to be interesting, and we've been preparing for this quite a while with the guys. And thank you very much. The right QR code, it's your feedback about the presentation, and left QR code, subscribe to our Inside Yandex Cloud Telegram channel. We have a public poll for t-shirts. You just have to subscribe, and randomly we will select several winners who will get those t-shirts. Thank you very much.
Вопросы?
Так,
Questions?
можно?
Yeah, sure.
Да.
А можете отлистать
Yeah.
на слайд, который
Can you go back to the slide about code analysis, secret analysis?
не с самого начала подключился,
Unfortunately,
такой
I didn't come here from the beginning, but I have a question. Do you have a service
репозитория кода, в
similar to a closed code repository, which in the library goes only after the review, or you don't have something like that?
Поближе или...
Can you keep the microphone closer?
Смотрите, я не
Can you hear me better?
подключился,
Okay.
вот,
I haven't been here from the very beginning.
в слайде про проверки я не увидел след.
In the slide about checks, I didn't see the following. If we're speaking about the concept of shift left,
До SAST
yeah, this one.
и сканирования на
Before SAST and vulnerability scanning and generation of SBOMs,
шаг, это
there is a feeling that there should be another step, closed code repository, where you don't take any library, but only the library that is going through certain litigate
который вы до этого
security team that has been set up. You don't have service like this, as I understand, right? Only in the framework of managed service for GitLab, we have closed repositories, if you're speaking about that.
окей.
Well, yes. Okay, good.
Следующий вопрос. Вот
I have another question.
detection, сканирование.
SaaS secret detection, vulnerabilities, bomb generation is wonderful, but I didn't see the following thing here.
Подрядчики могут
All your
да, то если у вас
raiders can use FIDAC, and do you have in your internal scanners examples of safe configurations and non-safe configurations? And do you do scanning
якобы
of your code
там, для ваших подрядчиков?
specifically for your contractors and services that can be used? This is about scanning.
SAST, можно так-то назвать, либо
It's like SAST analog or config checker, something like that.
безопасную конфигурацию
But safe and non-safe configuration of
есть у вас, либо у вас
those services that you have or your contractors might have. And do all of them have it, and do all of them can use VAA, and if everybody can do WAG, do they have safe and unsafe examples of configuration and automatic scanner? Well, I think this is a question to the internal security, right? Not only, it's to the cloud provider question, because if you supply solutions, certain solution, if you say that we can provide a SaaS service, so I would like to get information from you
по небезопасным
about SaaS, about non-safe configurations.
В данный момент только...
Well, as for SaaS, speaking about SaaS, we have the internal SaaS that GitLab has. We don't have our own solution.
очень понятно, ну,
So then it's not really clear.
Вот в этом.
Level managed service is not available from this point of view. Managed SaaS.
GitLab.
я понимаю,
It's inbuilt into the GitLab. Okay, I understand that. But you've said that your contractors, they go through some strict control. And I would like to understand what kind of a control and which criteria do you have in this strict control.
хотя бы подрядчики контроль того, что все изменения можно
Do they go through the control that all the changes can be done through the code? Through.
Контроль тоже проходит. Мы можем об этом...
Yeah, this control we do have, and we can speak about it separately. Yeah, of course. Thank you. Thank you.
Да,
You? You.
Или чтобы поближе.
Just speak closer to the microphone. Hello, thank you very much for the presentation. I have the following question. If the company uses not managed service from GitLab, but its own service, which recommendations would you give to achieve SLSA third level? When you are saying that you do comply, but you comply to some internal standards, and maybe through some transitive dependency that you will be certified, or you are. But if the company doesn't use managed service, but deploys everything with the help of GitLab, which standards one should achieve, and what's going to be the third level of SLSA? What are your recommendations? Okay, thank you very much for your question.
Того, как...
It's going to be as a recommendation. How with the help of those services which are available in the cloud, you can comply to the same SLSA. In principle, this can be done by some other services, like, for example, some vendor solutions, or, for example, the same GitLab can have a soft host on a virtual machine or somewhere in the on-prem. And this is just as a recommendation or presentation. Well, do you have any specific offers? For example, we have had our own GitLab, and in order to achieve level 3 of SLSA, what should be done by us with this GitLab, or maybe not GitLab, but something else? Well, from this point of view, you should have this third level Git mapping. Well, this third level, speaking about maps, and when you use managed one, right? But we use our own, not managed. So what is to be done by us?
Не до конца как будто понимаю вопрос в плане того, что...
Don't really understand your question from the point of view of what is to be done.
Достичь этого уровня, да? Вот вы же достигли, вы сделали все.
We have to achieve this third level. You've done everything according to the safety standard that you specify, but we don't use managed. What else should we do from our non-managed GitLab in order to achieve this level 3? Okay, I get you.
Он должен соответствовать стандартам.
Well, it has to comply to the standards from the security point of view. Which standards? Well, these are, well, everything depends on
Находится, если там в России
where you're located territorially. If it's in Russia, then it has to comply to the same
стандарт.
GOST, federal standards.
В
Then
проще.
in the cloud, from this point of view, it's much simpler because we separate responsibility. You separate responsibility with the cloud provider. For example,
Чек-листы.
there are certain checklists for which you are responsible and your data, and then
Собираем все это.
physical security, shatter resistance, and from this point of view, managed services are much more convenient in the cloud.
По поводу...
And then I have another question about responsibility. Did you have any idea to say how managed on GitLab, you can have some kind of a managed SLSA and something else like this? Yes, we did have some such ideas, but maybe in the future there will be a presentation about this particular topic. Thank you. Thank you. Yes, can you do it here, please?
И ребята изначально столкнулись с некоторыми проблемами с
And we have faced some problems
именно с тем,
with in-store, specifically that small store has some problems with automation
хранимых сертификатов. Ну и также есть
and checking the root certificates problem.
с
If we are looking at the question with signing the quits, and when we work with the developers, how you can verify
какие-то параметры.
the mail of the developer or some parameters that are connected to it. SLSA is not solving this problem at all.
Для именно цепочку поставок.
SLSA is more for the supply chain,
Да?
Ну, разработчик — это лицо.
but the developer is a key entity in the supply chain.
Допустим, Кусайн,
So if you use cosign for signatures, then you use its mechanisms. There's not a lot of them, and you need to store both your signatures and data, and you have to store certificates,
подтяжкой к разработчику.
pulling them to developers. That's where we have the problem with certificates and verification of the developer himself.
Сайн в данный момент он интегрирован с...
Well, cosign is integrated to our key management services, and when we are making the signature is stored in KMS,
Сигнатура, она попадает
and the signature
в принципе,
hits the registry container.
вопрос тому, насколько вы доверяете
But then we have a more question: how
это все хранить.
much do you trust the cloud? Because everything is being stored in the managed services like KMS and container registry.
И там хранилку секретов вы выбираете,
KMS,
либо что-то со стороны используете,
or you can select something of your own, or
либо что-то со стороны.
do you use your own KMS? Yes, this is our own managed service. Thank you. Thank you for the question.
Спасибо за доклад.
Thank you very much for the presentation. As I know, SLSA is a foreign product, and right now in the development there is a ghost which is related to Russia about the supply chain. And due to this, I have a question. What about right now? How this story is very actual for Russia? Because we're facing the situation that we look at the compliance of SLSA to the third level, and what other stories did you have? So what about the situation here in Russia? Well, speaking about the stories, we do have stories like that. We've been asked about how this can be done, and this is how we came with an idea of this presentation in our internal clients in our cloud. Basically, yes, we did have such requests, both for Ghost and other. SLSA is not the only framework like this, common framework, but it was taken here as one-off. Not very often, but yes, there are those who require this compliance. And as it was in the work with BOMs, there are users who are storing them, but they don't really understand how to work with them in the future. And the same in SLSA, how we can comply to these by using cloud services. Thank you. Thank you. Thanks for the presentation. Can we ask technical question about realization of this pipeline, or we are speaking about methodology of the process? I will make an example. Speaking about certification production, you use on a common certificate which can be called back, or you use the GPG signature. It's like one-time signature. The idea is that 509 cannot be called back, or vice versa. Okay.
Про какая-то техника, ее можно перейти вот никак не могу.
Well, the technical one, I cannot switch the slide. There's going to be a webinar that I've been speaking about, where we are going to speak about GitHub repository and a list to the webinar, and we're going to have more technical specifications. On this presentation, it's more theory, which refers to the practical examples. Okay, I get it. And about the technical one, maybe I will get the answer. Why do you use SIFT and not CSGen or other similar tools which are used for as bombs? SIFT. Why use SIFT? As an example of one open source tools? Just as an example. Just simply as an example. Yes, okay, I get it. And the final question, does it make sense of separating signature for different artifacts? Code, the artifact, SBOM artifact, container assembled, maybe some binary assembly, etc. Possibility of signing with cosign. Yes, it is possible as a block file. What about the signature of all the supply chain in the framework of the documents? About storage. Should you sign all the artifacts generated in assembly and supply, or do we speak about signing some important elements like code? The most important is the signature of the origin and the image. Yeah. Origin meaning the code. It's a metadata, how it was assembled. Okay. Which is generated by GitLab in this variable. What if we have signed the code, but the problem will come from the assembly point of the container? If they don't have validation of the signature, will these levels be available? The signature of the code is available. We checked it. It's wonderful. But after the container assembly, we checked it, and there's a problem. The final part of the question, the code that was developed, there is a signature, it's valid, but the container signature, but when the container was assembled, this signature is not available. Is it a violation? Well, yes, it is. Because then we cannot be responsible for this authenticity of the image when it moves to deploy. And is it truthfully that image that we've been assembling in the beginning? Because it was not signed on the level of assembly. So every artifact at any stage has to be signed. Yes. Yes. Okay, get it. Thank you. Thank you. Okay. That's it. Then we select the best question. I like the first question, and we will continue the communication on the first topic. Yes, please approach. Thank you very much for your attention.